Spleen, the body's hidden filter. The spleen is a secondary lymphoid organ in the upper left quadrant of the abdomen between 9th and 11th ribs. It is an intraperitoneal organ enveloped by the visceral peritoneum except at splenic hilum. The fibrous capsule which envelops it is made up of connective tissue and it forms short extensions into the organ called trabeculae. Splenic artery originates from celiac trunk and runs horizontally and retroperitoneally along the superior and posterior margin of pancreas. Key ligaments are gastrosplenic ligament connects spleen to the stomach's greater curvature and splenorenal ligament connects hilum with left kidney. The splenic vessels and the tail of pancreas are within the splenorenal ligament. Phrenocholic ligament attaches splenic flexure of the colon and diaphragm. Phrenosplenic ligament connects diaphragm to spleen. The spleen has two tissue types, white pulp and red pulp. White pulp is the main lymphoid tissue of spleen and contains lymphoid elements including follicles, lymphocytes and plasma cells. There are also macrophages residing in both white pulp and red pulp. Red pulp constitutes most of the spleen's volume. It consists of venous sinuses and cords of lymphatic cells including lymphocytes and macrophages. As blood flows, RBCs are pushed towards the narrow slits between endothelial cells. Only healthy RBCs can pass and old RBCs get stuck. Macrophages and dendritic cells capture these and present them to T and B cells. This triggers the activation of T cells into effector T cells. B cells produce and release antibodies which destroy antigens. Individuals without a functioning spleen are prone to high risk of infections. Reticular fibers and macrophages in splenic cords actively remove old or damaged RBCs and thus ensure a healthy RBC population. Additionally, red pulp acts as a blood reservoir, which is released during heavy bleeding or injury. Splenic cords are important reservoirs of macrophages. During severe tissue injury, spleen releases monocytes which facilitate healing of the tissue. Spleen also has a role in hematopoiesis during fetal development, but it can retain its capacity in situations where bone marrow function is compromised. Spleen also contributes to systemic homeostasis and metabolic regulation. It has a vital role in iron metabolism by restoring iron derived from degradation of hemoglobin. This can be used in cases like erythropoiesis or iron deficiency.